Okay, here's a new problem. A cart rolling down an incline for 5 seconds has an acceleration of 4 meters per second. If the cart has a beginning speed of 2 meters per second, what's its final speed? So, as you can see, I have this awesome drawing of our cart rolling down an incline. So let's pull out our bits of information. We have time, so we know that it's rolling down. It takes it 5 seconds in order just to get to the bottom of our measurement. That is, we have it accelerating. So because it's rolling down the hill, we know that it's going to get faster and faster as time goes by. So it's going faster and faster, 4 meters per second for every second that goes by. So we can even do a little chart just with these little two things. If it starts at 2 meters per second, so we have our initial velocity is at 2 meters per second, we want to find out what its final speed is. Okay, let's do this using a table. Let's do this in a slightly different way. Let's do this using a table. So if in our table we have our time and we have our velocity or our speed. So remember, velocity and speed, the two big differences between the two of them is just its direction. So for now, direction is not hugely important, so we can actually use them interchangeably. So one's called, we can call one speed and we call one velocity. For now, it's not a huge deal. Okay, now what if we were to actually make a table out of this? So at time 0 and up to 5 seconds, at time 1 second, 2 seconds, 3 seconds, 4 and 5. Now we know it's accelerating 4 meters per second every single second. However, we know that it actually starts off at 2 meters per second. So let's chuck that in. So it's already going, obviously here, our time is in seconds. It's good when we're doing the table. Our velocity is going to be in meters per second. We can add that in so that we don't have to put in the values every single time, the units every single time. So it's going at 2.0 meters per second at the start. Now, acceleration literally means for every second that goes by, that is how much the velocity increases for every second. So at 1 second, it's going to be 4 meters per second faster. So 2 plus 4 is 6. So after 1 second, it's going 6 meters per second. Now after 2 seconds, it's going to go another 4 meters per second faster. So it's going to go 10 meters per second. After 3, another 4, it's going to go 14 meters per second. And then another 4, 18 meters per second. And then after 5, eventually 22 meters per second after 5 seconds. So we figured that out using our table. We can also figure that out using an equation. So we have our original acceleration equals Vf minus Vi over t. We want to find Vf. So let's do a little bit of math. So if you don't want to go through the math, you can just skip forward a little bit. So if we multiply both sides by time, then you have acceleration multiplied by time. And if I multiply all of this by time, then I'm going to, so if I multiply all of this, so Vf minus Vi, multiply that by time, we're going to eliminate that because time divided by time is nothing. So we're going to eliminate that. So all we're going to be left with is final velocity, take away initial velocity. Awesome. So we want final velocity. So what if I added initial velocity to both sides? That would mean this would become initial velocity plus acceleration multiplied by time. And if I add initial velocity to like a negative initial velocity. So if I said, if this were different, if this were like Vf plus Vi minus Vi, then these two would actually just cancel out. That would cancel out. So we would be finished with Vf equals Vi plus At. And this is actually our equation that we're going to be using. Final velocity equals initial velocity plus At. And you can actually look at this. We can actually prove this according to our table, because our acceleration is 4. So let's say at 4 seconds, 4 times 4, what's that, is 16, plus however fast we were going at the start, which was 2 meters per second, right? So 16 plus 2 is 18. How about at 2 seconds? We were initially going at 2 meters per second, and then we are accelerating at 4 meters per second. So 4 times 2 is 4 2s are 8. Add 2 to that is 10. So we can actually now have a look at any single spot. It doesn't matter what time, we can actually figure out how fast it's going right at the end. So just to prove it one more time, we were going at 2 meters per second 2 meters per second at the start. Okay. And then we went for 5 seconds, and for every second that went by, we were getting 4 meters per second faster. So 4 times 5, that's 20, plus 2 equals 22 meters per second, which is our answer according to the table.